Alright, so the purpose of this video is to take a look at how energy moves through an ecosystem by taking a look at food chains, food webs, and energy pyramids, defining various trophic levels, and also talking about how nutrients are recycled. Food chains and food webs take a look at feeding relationships and how that links primary producers and consumers. Food chains and food webs show how energy flows in one direction from primary producers to the consumers. A food chain is going to be a series of steps that shows the transfer of energy between organisms based on what's being eaten and what's doing the eating. And so if we look at, for example, an aquatic food chain, like what's shown here, we take a look at where our producer, and it's going to show kind of one line of what's being eaten and what's doing the eating. So we can define the different types of consumers. These and the primary producer are going to be different trophic levels as well, or different levels of the food chain and food web. So we have the primary consumer. This will be the first consumer that takes energy from the primary producer. So this would be the flagfish, and that's going to be an herbivore or an omnivore. So it's something that eats plants or would eat the primary producer, or in this case, algae as well. So we have secondary consumer will eat the primary consumer. So this would be secondary consumer will eat the primary. And then we have tertiary consumer. So tertiary consumer will eat the secondary, and quaternary consumer, or the fourth consumer, will eat the tertiary consumer. So the energy is going to be very great here. And then as you go down the food chain, the amount of energy available in the system will be a little bit less. So that's a food chain. A food web is going to be a network of feeding interactions. It's going to be more complex and more complicated than just a simple single food chain. A food web is going to link together many food chains, and it's really going to be a better representation of how everything's related within an ecosystem, because it shows animals are eating more than one type of food, they have more than one type of consumer. So here's an example of a food web. And so you can see our original food chain here, algae, flagfish, all the way to the alligator. But you can see that it's also part of a bigger network. So the algae is also eaten by shrimp. The shrimp are then also going to be eaten by the bass and eaten by this fish or by crayfish. And so you're going to see a lot of interactions. What this means is that the food web helps us to see the interaction better. So if we eliminated the anhinga, well then now maybe the largemouth bass population is going to increase a little bit because it doesn't have now the predator that it originally had. And so whenever we look at food webs, it helps us to see impacts on a bigger scale. Food webs also show us decomposers and detritivores and shows us how they're important for recycling nutrients. This is because a ton of producers are going to die without being eaten, and so decomposers have to convert that to detritus so that then the nutrients can be released back and then used by the primary producers again. Like I mentioned before, food webs are going to help us to see the disturbances and the impact that different disasters can have. For example, we'll take a look at krill that feed on algae, and so if algae decline, then krill decline, and then everything else will decline. So if we look at that, so we have algae, krill feeds on that. So if algae decreased because of some sort of environmental disaster, say, then now the krill will increase and we'll be able to support less organisms as you go through the food web. So decreased amount of algae, which decreases krill, could ultimately impact something like the killer whale, because now all of the organisms that eat the krill are also going to be impacted. So when we look at food webs and food chains, we talk about trophic levels. That's going to be each step in the food chain or food web. And so producers are always the first step, and then we have our primary consumers, secondary, tertiary, and quaternary consumers. We'll also take a look at ecological pyramids, pyramids of energy, biomass, and numbers to show the relative amount of energy that's available at each trophic level. So pyramids of energy are going to show the relative amounts of energy. The important thing to remember about this is that only about 10% of energy in each level is stored by organisms at the next level. So if you start out with 100% of energy, then the next level only has 10%. So much of the energy is spent on moving, growing, reproducing, doing cell respiration, and it's being released as heat. So the impact that this has then is that there are more organisms at the bottom of a food chain, so there's more total organisms than what there would be at the top. So here's what a pyramid of energy looks like. So again, you're decreasing by 90%, meaning that only 10% of the energy moves on to the next level. It's all being released as heat. We also have pyramids of biomass, which is looking at like how many kilograms of mass would be available of organic material at each trophic level. This is going to be impacted by how much energy there is. So if there's more energy, then there's more biomass. We also have pyramids of numbers, which shows the relative number of individual organisms at each level. Normally it's going to be the same as the other pyramids. It can be inverted if you have a larger number of consumers than the producer. For example, if you have a tree as the single organism that a bunch of consumers are using. So generally, biomass and numbers, the pyramids look like this, where you have large biomass and large numbers at the bottom, and it gets smaller as you go up because, again, only 10% is being transferred to the next level. So if this is 100, this is 10, this is 1, and this is 0.1. Here's what an inverted pyramid would look like. Again, if we had producers, we have one tree and then a bunch of birds, then you would have an inverted pyramid. We don't see that quite as often. Typically we see this, and again, only about 10% of kind of that biomass or those numbers are going to be translated up to those upper levels.